come on a journey to learn about physics. Awesome physics with Mr. Momentum.
I don't understand this. How does special relativity work?
Ouch.
This looks like a job for Mr. Momentum!
Wow, it's Mr. Momentum!
I'm gonna teach you some awesome special relativity.
Thank you, Base Mr. Momentum.
Stephen Harper sadly watches a ball drop. The ball falls straight down. Justin Trudeau is in a cart going at a constant velocity towards Stephen Harper. He watches a ball drop and it falls straight down just like Stephen Harper's ball. Why does this happen? They're both inertial reference frames and they will observe the same laws of physics. An inertial reference frame is any frame of reference that is moving at a constant velocity. Both Stephen Harper and Justin Trudeau are moving at a constant velocity and are valid inertial frames of reference. There is no preferred inertial frame of reference, which means they could both say they are moving relative to each other. There's no absolute frame of reference, which means there's no such thing as an absolute state of rest. Now there is another Justin Trudeau in a cart dropping a ball and putting on the brakes and accelerating opposite to the velocity of the cart. The ball moves differently from the balls dropped by Harper and the first Trudeau. It is a non-inertial reference frame because it is not moving at a constant velocity. The ball behaves differently from the other two frames because it is a non-inertial reference frame. Inertial reference frames are important to special relativity.
Surely this can't relate to special relativity.
It doesn't, don't call me Shirley. Schrodinger's cat, which is alive, is on a cart moving to the right past Schrodinger. Schrodinger sees two lightning bolts hit both ends of the cart at the same time when the cart's middle is right in front of Schrodinger. Schrodinger would say that the lightning bolts hit both ends of the cart at the same time. Now you would think Schrodinger's cat would see the lightning bolts hit the cart at the same time like Schrodinger, right? Wrong. The cat sees the right end of the cart get hit first with a lightning bolt. Why does this happen? Light moves at a constant speed of 3.0 times 10 to the 9 meters per second. It cannot go any faster than that. It takes the right lightning bolt's light longer to reach Schrodinger than it does for the left one due to the train's movement and light having a constant velocity that doesn't change. So in order for Schrodinger's reference frame to see the lightning bolts hit simultaneously, the cat's reference frame must see the right lightning bolt hit before the left. This is called relativity of simultaneity and shows that two spatially separated events are not absolute to happen at the same time and depend on the observer's reference frame.
Wow, special relativity is so awesome.
But wait, there's more! So there's a giraffe on a rocket sled going 90% the speed of light. The giraffe has two mirrors in its stomach and a light beam bouncing off the two mirrors. There's a window on the side of the giraffe's stomach to see inside it. From the giraffe's point of view, the light beam bounces straight up and down. The light beam is moving at a constant speed of 3.0 times 10 to the 9 meters per second and doesn't change no matter what reference frame you're looking at. Now we introduce our unimpressed observer. He is watching the giraffe go by and sees something else different from the giraffe. Notice the light beam has to travel up and down and also moves horizontally. This means it moves a greater distance. But wait a minute, isn't the light beam moving at a constant speed that doesn't change depending on the reference frame? So what changes? It turns out time does. In the giraffe's reference frame, time is going much slower than the observer's reference frame. To compensate for the change in distance, light has to travel between reference frames. The faster the giraffe goes, the more time slows down for the giraffe. This is called time dilation and is a very important part of special relativity. A neat thing that happens as part of special relativity is the giraffe will appear to be shorter along the point of motion for the observer than the giraffe. The faster the giraffe goes, the shorter the giraffe will appear to the observer. This is called length contraction.
And that's how you do special relativity.
That was swag.
I go now.
Bye, Mr. Momentum, I'll miss you.
Bye, little Jimmy. I'll miss you more.